Welcome to TED Talks. We are still focusing on biology with me, Simon, and advanced level biology. Our main focus in this is going to be on understanding nucleic acids. Nucleic acids. We have so far looked at various chemicals of life. We have looked at water, we have looked at carbohydrates, we have looked at proteins, we have looked at lipids. Now this is the fourth organic chemical of life we want to focus on too. So what are they? So we can say these are complex organic molecules made up of atoms of carbon, hydrogen, nitrogen, oxygen, sulfur, you can put there, and phosphorus at large. So they're made up of these atoms. We have found several compounds that are made up of such atoms, but they are not nucleic acids. And the ratio of these atoms in nucleic acids is different from the ratio of nitrogen and other atoms in proteins and other substances. So we can expand them further and say nucleic acids are made up of a combination of a carbohydrate, pentose sugar, deoxyribose, or ribose. Shall expand that. An inorganic phosphate and a nitrogenous base. So let's first look at the pentose sugars present in nucleic acids. Pentose sugars present in nucleic acids. Remembering from our part of monosaccharides, a pentose sugar has 5 carbon atoms and it is a furan. There is no way it can be a pyranose. So our pentose sugar ribose, if we are to draw it here, it has C5H2N, that means 10, or N, that means this is 5. Deoxyribose has C5H10 or 4. So how do they look like? Ribose is a furanose, so it means it takes up a 5-sided ring like this. If we are to name these carbon atoms here, this will be carbon atom number 1, 2, 3, 4, and 5. So how many oxygens do we have so far? We have 1 oxygen, 2, 3, 4, and 5. Those are 5 oxygen atoms present. How many hydrogens? Can put here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's how a ribose sugar molecule looks like. Then a deoxyribose sugar molecule still has 5 carbon atoms. That means it is a furanose. It means there is carbon there, carbon, 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 then another carbon here. Then how many oxygens? You have oxygen there, oxygen here, oxygen there. Those are our 4 oxygen atoms. Hydrogens, we put them there. Put them there. All the 10 hydrogens. So where is the main difference between ribose and deoxyribose? Carbon atom number 2 lacks oxygen attached to it. That's why it is called deoxyribose. Otherwise, they have the same furan ring and different molecular formulae. Those are ribose sugars, rather pentose sugars. Then you can look at the nitrogenous bases. Nitrogenous bases. The nitrogenous bases are subdivided into 2. Pyrimidines, these have a single 6-sided ring, and they are called, one is cytosine, and 2 adenine. So think it is cytosine, yes, and adenine. So this is abbreviated as C, this is going to be abbreviated as A. So they take up a 6-sided ring, but with nitrogen in it there. Such a ring is what they take up. So they are called pyrimidines. So I'm going to be represented in our subsequent sessions with a C or an A. Then B, we have purines. These have double rings in their structure. So the first one is guanine, which is going to be represented as capital G, and the second one is thiamine, which is going to be represented as capital T in our subsequent discussions. So you can go further and look at the phosphate, the inorganic phosphate. The inorganic phosphate is H3PO4. That's where our inorganic phosphate comes from. So when they unite, a base unites, an inorganic phosphate unites, and a pentose sugar unites, we come up with something we call a nucleic acids. So in a subsequent discussion, let's come back and look at the structure of the simplest nucleic acid, which we are calling a nucleotide. How do these three components unite to make nucleic acids?